Alright, so my name is Arianna Fisher. I am currently a junior at Lakeland High School, and I'm enrolled in the dual enrollment Precalculus course that is offered at my school, Math 161 and Math 114. These classes are offered through Paul D. Camp Community College. I decided to enroll in this course mainly because I wanted to better my math skills and prepare efficiently for my AP Calculus course that I'll be taking senior year. Today I'm going to be discussing polynomial division. The textbook that I'm going to be using and referencing throughout this lesson is called Precalculus, Graphs and Models, a Right Triangle Approach, the 5th edition. I will be working off of page 331, and I'm going to be focusing on problem 11 and problem 19. Okay, so the directions of this problem say to use synthetic division to find the quotient and the remainder of both of the problems. So the quotient of a division problem is the answer. If in long division, it would be the numbers that you get on top of the line, and the remainder is what's left over or what does not fit in the actual problem. It's just the leftovers. So we're going to be starting with problem number 19, which is x raised to the 4th power minus 1 divided by x minus 1. So before we begin, we have to set x minus 1 equal to 0 to figure out what we're going to be using, the number itself, what we're going to be using to solve and divide by. So x equals 1, that's the number we are going to use to solve the problem. In long division, the number 1 would be what we would be on the outside of the little brackets. So in synthetic division, you want to place this number, the x minus 1 number, which ended up being positive 1, inside a bracket to separate it from the rest of the problem and to show that you're dividing the rest of the numbers by this number. So now we have to determine the numbers that would be under the brackets in long division, and we're going to get that from the coefficients of the x raised to the 4th power minus 1. So like I said, the numbers we're using are the coefficients of these values. We have to use each coefficient of each degree of this term. So even though they're not pictured, x to the 4th power, x to the 3rd power, x squared, and x alone are all the degrees in that one term. We have to put placeholders in there because that's how synthetic division works. We're trying to end up with a quotient of this long term. So for placeholders, we use 0. That's the mathematical rule. Okay, so you do nothing to the leading term, you just bring it straight down. So here I bring 1 straight down to 1. So the next step is to multiply the leading term by the number in the box, which is 1. Then you want to add the next, which is 0, plus the 1. And then multiply 1 times 1, follow it over, 0 plus 1. 1 times 1 once again, bring it over to the zeros. 0 plus 1 is 1. And then what you want to do is one more time, 1 times 1, negative 1 plus 1 is 0. So all of these numbers are going to represent the coefficients of the quotient, which is what we're solving for. Now the 0, whatever number is left, the last number in the problem like this, when it's set up as synthetic division, is always going to be the remainder. Here the remainder is 0, so there's no leftovers, and if this was a long division problem, there would be no leftovers. So once again, these numbers, the 4 ones and the 0, they represent the coefficients of the degrees. So the first number 1 would be the coefficient of the x to the 4th power, the second number 1 would be the coefficient of the x to the 3rd, and so on and so forth. Now you don't show 0 in the actual problem because there's a number 1 that represents the constant in this problem. So what I've written, x to the fourth plus x to the third plus x squared plus 1 is the quotient, which is one of the things we should have been looking for, and 0 is the remainder, which is the other part of the problem. So once again, the answer is x to the fourth plus x to the third plus x squared plus 1, because we took all of the numbers that we found in synthetic division and put them as the coefficients of each degree. Alright, so on to problem number 11, which is 2x to the fourth plus 7 to the third plus x minus 12 divided by x plus 3. So this problem is going to start just like the last one did. We have to figure out what number we're going to put in the little box, which is the number we're dividing by. So we take x plus 3 and set it equal to 0. And then we solve, and this ends up being x equals negative 3. So negative 3 is the number we are going to be using to divide by in the synthetic division. In long division, you would just put the whole x plus 3 in outside of the brackets. So like I said before, the main object of synthetic division, we're just focusing on the coefficients of the terms. So here I'm underlining them in orange. And like the last problem, there's a degree missing, which is the x squared. So we always have to remember to put a placeholder there because it's still relevant. So the coefficients are underlined. Like I said, don't forget the missing term. The missing term should be put as 0. And then we label the rest. So the coefficient of x to the fourth is 2, the coefficient of x to the third is 7, the coefficient of x is 1, even though it's not pictured, and then so on and so forth. So like I said, bring the leading term straight down and don't do anything to it. Multiply the leading term by the number in the square, bring that over to the next column, add those numbers to get 1, multiply, so we would be multiplying negative 3 times times 1 to get a negative 3, and then so on and so forth down the line. You just take the number from the leading coefficient, multiply it times the number you have in the bracket, put it in the next column, and add the columns down. So we took 1 times negative 3 to get 7 plus negative 6. We took negative 3 times 2 to get 7 plus negative 6, 1 times negative 3 to get 0 plus negative 3, negative 3 times negative 3 to get 1 plus 9, negative 3 times 10 to get negative 12 plus negative 30. And the answer to negative 12 plus negative 30 is negative 42. So like I said before, the number in the last column is always going to represent the remainder. So that's one part of the answer that we have found. And the other numbers that we solved and found with synthetic division are going to represent the coefficients of the quotients. And when writing the quotient using synthetic division, you always go a step down. So this polynomial started with an x to the fourth power. So when we're rewriting it in quotient form from just the coefficients, you start off with an x to the third power. So the final answer, final quotient, is 2x to the third plus x squared minus 3x plus 10. And we cannot forget the remainder because this time we have one. The remainder, what's left over, is negative 42. And okay, so synthetic division is an alternative to long division. It's more simple. Um, Synthetic division basically focuses on only the coefficients of a specific polynomial, and then it also incorporates a factor of that polynomial. The goal is to get the quotient, which is just the number that you get when you divide two numbers together. In order to solve for these coefficients, we take the leading coefficient and then multiply that by the number that's in the box. Once we get that number, we put that in the next column over, next to the leading coefficient. Add that column, top plus bottom, and then get a number. Multiply that number again by the number in the box, and repeat the process until we come to the end.